Today we are working on section 5.5, which is to write equations of parallel lines and perpendicular lines. Parallel lines have what kind of slope? Parallel lines have the same slope. All equations in this section are going to be finished in slope-intercept form. That'll make it very easy for us to look at the slope. We're going to write an equation of a line that passes through negative 3, 3 and is parallel to the line y equals negative 2x plus 1. We first need slope in order to write our equation, and we know that if two lines are parallel, they have the same slope, then our slope is going to be the same as the equation we're going to be parallel to. Slope is equal to negative 2. Using that slope and the point that the line needs to go through, let's put it into point-slope form. So we'll have y minus y1 equals m times the quantity x minus x1. Substitute your point and slope into the equation. We'll have y minus 3 equals negative 2 times the quantity x plus 3. Use your distributive property on the right-hand side. We'll have y minus 3 equals negative 2x minus 6. And then we need to put this in slope-intercept form. So we'll have y equals negative 2x minus 3. The equation that we just came up with is parallel to the line that they asked us to be parallel to. And please notice the slopes are the same. In order for those two lines to be parallel, their slopes have to be equal. And our line goes through the point negative 3, 3. That was what we used in order to get to this equation in the point-slope form. Let's write another equation of a line that passes through the point negative 2, 11 and is parallel to y equals negative x plus 5. Again, since it's going to be parallel, it needs the same slope as the equation of the line we're parallel to. So our slope is going to be a negative 1. Substitute negative 1 and the point negative 2, 11 into point-slope form. We'll have y minus 11 equals negative 1 times the quantity x plus 2. Use your distributive property on the right-hand side. So we'll have y minus 11 equals negative x minus 2. And then let's put this in slope-intercept form. We'll have y equals negative x plus 9. That's a negative 1 times x plus 9. This equation, again, is parallel to the given equation that we had because their slopes are the same. And it goes through the point negative 2, 11 because we used that point in order to come up with the equation. Perpendicular lines form what kind of angle? Perpendicular lines form a right angle. Slopes of perpendicular lines are negative reciprocals of each other. Perpendicular lines have negative reciprocal slopes. This is an important piece about perpendicular lines. We know that two lines that are perpendicular form a right angle, and the slope of one might be 2, but the slope of the other one then has to be a negative 1 over 2. So they have to be reciprocals of each other, and one is the opposite of the other. That is called a negative reciprocal. Let's determine which of these lines, if any, are parallel or perpendicular. We're going to start out with our three lines A, B, and C, and let's put them into slope-intercept form if they aren't already in that. Line A is negative x plus 3y equal 1. And when we start working with that, it gives us 3y equals x plus 3. Let's divide by 3 on both sides and have y equals 1/3 x plus 1/3. That equation's now in slope-intercept form. Line B is already in slope-intercept, so we don't have to do anything to it. Y equals negative 3x plus 1. Line C is needed to be put into slope-intercept, so let's go ahead and subtract 2x on both sides. Have negative 6y equals negative 2x plus 4. Then divide by negative 6 on every term and have y equals 1/3 x minus 2/3. Look at the slopes of these three lines. Line A, line B, and line C. I see line A's slope as 1/3, line B's is a -3, and line C's slope is 1/3. We know that when we have two slopes that are the same, we know those two lines are parallel. So we're going to say A is parallel to C. Notice the little railroad tracks in between A and C. That's the parallel symbol. Then, please notice that -3 is a negative reciprocal of 1/3. So since we have slopes that are negative reciprocals, we can say that B is perpendicular to C and B is also perpendicular to A. So we're looking for these three answers. A is parallel to C, B is perpendicular to C, and B is perpendicular to A. Let's write an equation of the line that passes through the point 4, -2 and is perpendicular to the line y equals 4x plus 2. Since we're working with perpendicular, we know the slope is not equal. That would be parallel. The slope has to be a negative reciprocal. Well, this equation's slope is 4. The negative reciprocal of 4 is a -1/4. Please remember that the slope must be a negative reciprocal. Now we can use that new slope that we have and the point 4, -2 and substitute them into point slope form. So we'll have y plus 2 equals -1/4 times the quantity x minus 4. Distribute on the right-hand side, and you'll have y plus 2 equals -1/4 x plus 1. And then get it so that it's in y equals slope-intercept form, y equals -1/4 x minus 1. Notice that our equation that we have has a slope of -1/4. The equation we want to be perpendicular to has a slope of 4. So these two lines are perpendicular, and this line goes through 4, -2 because we use that point in the point slope form. Let's write an equation of the line that passes through 4, 3 and is perpendicular to the line y equals 2/3 x minus 7. Again, we need to come up with what the slope's going to be when lines are perpendicular. If our slope is 2/3 in our original equation, then we need the slope to be a -3/2. Remember the negative reciprocal for slope. So plug in our new slope, -3/2, and our point 4, 3 into point slope form. Y minus 3 equals a -3/2 times the quantity x minus 4. Distribute on the right-hand side, and we'll have y minus 3 equals a -3/2 x plus 6. And then put it in slope-intercept form. That's y equals -3/2 x plus 9. Again, this equation has a negative reciprocal slope compared to the other one, so they are perpendicular to each other, and it goes through the point 4, 3 because that's the point we used in order to write the equation. Let's find the path of a golf ball bouncing off a curved wall on a miniature golf course. All right, they give us the two equations there, the lines A and B. They appear to be perpendicular, but really, are they? Well, line A, let's put it in y equals mx plus b form so that we can see what the slope is. So we have 3y equals 2x minus 1. Divide both sides by 3, and we'll have y equals 2/3 x minus 1/3. The other equation is 2y equals -3x plus 21. Well, divide everything by 2, and we'll have y equals -3/2 x plus 21 over 2. All we are concerned with here is our slope. The slope on the first one is 2/3. The slope on line B is -3/2. If they're perpendicular, those two slopes have to be negative reciprocals of each other. They are negative reciprocals. How wonderful! So since they are negative reciprocals, those two lines are perpendicular. That's all for section 5.5. Please remember, parallel lines have same slope, perpendicular lines have negative reciprocal slope. Thank you.